Hey everybody, I just wanted to get a little video together as we get into our new unit. This is Unit 8 in the textbook, Sequences and Series, also on Khan Academy. It's by that title. So basically, the sequence and the series have a lot in common. A sequence is just an ordered list of numbers. So, the most obvious basic sequence we could come up with are just 1, 2, 3, 4, all the way up to n. So you'll see n quite a bit, where n in this case is just going to be basically any term, right? Like it's the number of the term. So in this case, the term is equal to the number of the term. So the domain, if we're talking about the domain, is just the inputs, which are basically the terms themselves. Those are the n values, whereas the range would be the actual term. So in this case, they're one and the same for this basic one. But we could also have one of a different format. So like the first term, the second term, the third term, the fourth term, all the way up to the nth term. That goes a little bit differently. Like we could go by twos, all the way up to so this is where you may wonder, well, where do I stop? Well, we have finite series that end somewhere, right? A finite means it's going to end at a certain value, but we also have an infinite, or sorry, I think I said finite series. A finite sequence, it has a limited number of terms. But an infinite sequence is one that would go on forever. So we see that would just maybe be where we had a ... at the end. So the thing is, with these, we can start to determine some properties. For instance, if something goes up by a constant add, addition, or subtraction, we call that an arithmetic series. Whereas if it goes up by a constant multiplier, we call that a geometric series. So you may think of an arithmetic corresponding to a linear equation, and geometric would correspond to a exponential equation. But as we get into series, they're going to be a little bit different. Versus infinite. Never ends. This one ends. So if I look at a series is simply when the terms of a sequence are added together. So you get, for instance, if instead of just having 2, 4, 6, 8, if I had 2 plus 4 plus 6 plus 8, this is a finite series because they're being added and it ends at 8. And what we're going to have is this new notation, which we could call summation or sigma notation, because what it does is it allows us to write when we're adding up multiple terms in a series, like we do with series. And so what you'll see is in the textbook they use this variable I, where I is sort of, you could think of it as the initial value that you're plugging in. And then or often it's described as the lower limit of summation. And then up above the sigma, that 4, that would be the upper limit of summation. And what you're basically doing is plugging in these values. So what this would then just equal is 1 is going to go in, that's my lower limit, so it'll be 2 times 1. And then I'm going to do every integer up till 4, so it'll be 2 times 2 plus 2 times 3, and then the upper limit is 4, so that'll be my last one. And as you can see, this is exactly what was here. So this is actually a shorthand way of writing this. And you might say, well, Mr. Tannen, this doesn't look like shorthand. But imagine if you had, say, 100 or 60 terms. Obviously, you would want to use this notation rather than writing out all the terms like we have it up here. We could also, though, have summation notation. Let me change colors here, maybe to a nice red, where the upper limit is infinity. That would be an infinite series. So we could have this exact same summation, but in this case it's just going to be 2 plus 4 plus 6 plus 8, but it's never going to stop, right? It's going to keep adding up forever. In this case, it's just going to get bigger and bigger and bigger and not approach anything. But in certain cases, it could approach something, and we'll talk about that in future videos. But that's the basics here for what a series or a sequence in series is. Again, what's important and what you'll see in sections 8.2 is when you have an arithmetic sequence, it has a common difference, which we often use the variable d to specify as the difference. And you could have an arithmetic sequence or series, common difference, so that could be positive or negative, so it could be going up or down. Whereas a geometric series, as I believe you'll see in section 8.3, geometric sequences and series, we often say that those have a common ratio, or you could think of it as a common multiplier. So if you divide any term by the previous term, you should get the same ratio no matter what. So that would be a common ratio. So let me give a quick an example of each here. So for instance, arithmetic could be 1, 7, 13, 19, 25, 31. I could keep on going like that, whether it's infinite or finite. And for a geometric series, you can see I'm just adding 6 on that previous one. That's what makes it arithmetic. For geometric, I could have something like, let's say 256, 64, 16, 4, and 1, which is where each one I'm multiplying by a quarter or dividing by 4. You could think of it either way. If I divide any term by its previous term, 64 over 256, that's 1/4. If I do the same here, 16 over 64, that's also 1/4. 4 over 16, so on and so forth. And of course, it could also go the other way. So there's example 1. It could also just be something as simple as 6, 12, 24, 48, 96, where I just have a multiplier of 2, right? Times 2 each time. Hopefully my math has been correct. So that's the difference between arithmetic and geometric sequences and series. And you'll get to look at some of the algebra, and you'll see arithmetic corresponds, as we said, to linear functions, whereas geometric corresponds to exponential functions, because that's constant addition for linear, constant multiplication for exponential. Hope this video gives you a little more context in supplementing your reading or your Khan Academy. I'll come out with another video soon, so look out for both. Hope everybody's doing well. All my very best.